Good morning, everybody. My name is Boniface Simpoli. I'm here with you to present just a bit on food consumption. We are going to look on food consumption proportional from our Tanzania National Panel Survey Wave 5, NPS 2021. We're going to use STATA and Excel to compile food consumption proportion of Dodoma Region. So stay tuned with me. I hope you are going to enjoy very much on how to come up with this visualization by using a pie chart. Okay, first of all, we must have a STATA software. For me, I'm going to use STATA 15 versions and Excel 16. So first of all, we are going to look on our data sets, NPS data sets. In NPS data sets, we are going to use a section A, which comprise of identifications of data sets, and the section J1, JA1, which comprise of issue related to consumption. As you can see from our questionnaire here, in section J, there is all information related to food consumptions over past 1 week. So these sections, we're going to merge it with section A, which comprise of about the section A, which comprise about household identification. So first of all, we're going to upload a section A. Section A. This is a section A. We're going to upload. I have here. I have a do file here which comprise a lot of codes. I'm going to share with you all of this. So we have to merge section A and section J A1s because section A comprises all information related to household identifications, while section J1A comprise information about food consumption in households in last 7 days. So we have we have a key variable Y5 HHID in our data sets. So we have, this is a unique household identification. So we have this variable in both sections. We have it in section A and we have it in section J. So we are going to use it as a variable, a unique household identification to merge these two sections of datasets. Okay, so in merging two datasets, first we have to come here on data, then merge two datasets. Based on, as we know, these datasets are as blows to look how they look like. You can see that once I blows them, you can see that on on Y5 HHID, there is only one per observation. So only one households have one each households have unique observation when it comes to Y5HHID. There is a unique, but when it comes to the datasets in section J1A, you may find that one household may comprise more than one household's ID, because it means that household can consume more than one type of these agriculture products. That's why there is a lot. There is not. Y5 HHID is not uniform for all. There are some duplications. You may find one household may consume more than one food item. So once I want to merge these data sets, so it means that I'm going to merge one to many. One household may consume more than one product. That's why it's one to many Y5 HHID. That's why we come up with this criteria. So I'm going to deploy, to execute the section A, as then once I execute it, then I'll come, as I told earlier, I'll come on data, then I'll select merge two data sets. So we're going to merge one to many key variable, and our key variable here is Y5 HHID, and I'm going to merge it with section J. I'm going to merge it with section JA1. Okay, so you can find that from master there is 419 where those variables are merged. So we have on total this merged data set. Then from there, now we have a data set which comprise the consumption issue of households, food items with the household's ID, identification, where we can have the issue related to Dodoma specifically and ignore other regions. So from then, the first steps is to drop merged variable. Once you merge two data sets, normally there is a new variable which is created here. As you can see, once I browse it, it show those data sets which are matched either in master only or matched. So nothing to do with that variable rather than to drop it. So I drop it, so we don't have it anymore in our new created data sets, which comprise of section A and section JA1. So the next issue here is to change a unit. We may find that during our entry procedure, there are some questions. There is an option to select a unit of measurement in a certain product. You may find there is an options either to put a grams, kilograms, liter, milliliter, and the piece when it's come to the unit of measurement. So here we need, as we know, that almost grams and kilograms as the same unit of measurement. So we have to convert them so as to have just a single unit of measurements, either to be on kilograms or to be on grams. So for those for those products where the measurements are either in grams or kilograms, like rice, maize, and so on. So for us, we are going to convert those those products, with grams to kilograms. So here we have a command here. So we have to create a new variable which is going to 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 to, to divide those variable which are in grams with thousands to have kilograms. Uh, Once in question J021, it is coded as grams. That's what we come up with these commands. So we are going to code only. We're going to generate a new variable if in these questions the coding was only 2. Once it is in gram, then we are going to divide it with the thousands to have a gram new variable. So we're going to run to execute these commands in our starter files, as you can see here. So we have generated a new variable called the product kilogram. So for those who respond in grams only. So once I browse this data set, you can see that, okay, let me browse two of them. The new created variable vis-a-vis the original one. So to see how you can see how this variable have been converted. So okay, so let's look how they look like. So you can see that for those variable where it was in grams, it is a new variable. It is divided by thousands to be in kilograms. So and otherwise the one who are in kilograms, it creates a variable which is a missing variable. So we need to have new command to replace this missing to its original value. So for those who is missing, we are going to replace with its original value and keep it on those who are in grams. So we have to create a new. We have to replace. So we have to replace a new created variable with original value. Once it is the new created variable are missing. So this is a new command which is going to replace this missing value to have its original value, as we see as a missing value we can do. So we have this replace commands. As you can see, we can replace here. We just paste. You have to paste. Okay, let me copy it again. Is there something wrong? Let me copy it again, and I can learn it to replace those missing values. So we had okay, we had we made some changes. So it is 41,595 real changes made. So we replace this observation, and we can look on them and see how the variable is look like. Okay, now, wow. So new variable created, we replace it once it is not in gram. As you can see that the unit of measurement still remain once it was missing. So now we have new product. We have a new variable which it is in grams, no kilogram, and no gram anymore. All variable are in kilogram, or for those which were in gram. So for now we have a variable in gram only. So how about the liters, milliliters, and the piece? So these are mix-up unit of measurement. So and the next steps is just to keep only one, to have only one unit of measurement. So for those who are in another measurement unit, like liters and so forth, we have to drop them. Okay, we have to drop them and to keep just a variable with I mean the product with a single unit of measurement. So those with liter, milliliter, and the pieces, we have to drop them to remain with the variable which have a unique just to have a unique measurement, so as could be easy for each of comparison. So we have so we once you come back to our questionnaire, you may find that we have to drop, we have to keep. We are going to use these questions where there is kilograms and the grams. So we have to keep two variables. I mean, we have to keep only product with these two response, 1 and 2. So we're going to keep them. mm, so we are going to keep. Okay, first we have to. Okay, sorry. First we have to keep to remove those. I mean those missing values. So we have to on this we have these questions which it is yes or no. So we have to keep only households which consume at least one of these products. So those households which don't consume any of these products, once they respond no for any of these products, we are going to drop them. To have those households which at least consume one of these consume one of these list of the products. So I have to drop those households which don't consume one of these products to remain with those households which consume at least one of these products. So we have to drop them. We have to keep. There is two options: either to drop others. You can drop once it is two, or you can keep one. That's as these are two different commands with the same. I mean, meaning with the same meaning: keep or drop. So we are already we are going to keep and they drop these two, I mean, these observations. So for now, we have remained with only variable, I mean, with no only a variable which a household consume at least one of those products. So as you can browse, you can find that we no longer having missing value over the new created variable. So we remain with those households which consume at least one of the products listed product from the questionnaire. So for now, we go back uh, to our second command is just to remove to remain with a product with a single unit of measurements, to remain with the product with in grams and kilogram, and to leave those on liter and the milliliter and the piece. This for the issue of comparison. So this is the second inch to do with this data. So we are going to keep only 1 and the 2, those product with 1 and the 2 response in question 2. So this is the second command. You just keep if the response on question 2.1, it is kilograms or grams. So this is a command just to remove or to drop downs those variable which are not in either grams or kilograms as unit of measurement. So okay, 51 almost 51 observations are deleted from this command. So we remain with products which are in in grams and kilograms only. So this will help us once it comes to the issue of comparison. Once it comes, you cannot find any more issues related to liters, issue related to piece, and so forth. So for now, we are now looking. Okay, for our case is just to have an issue of Dodoma. So we have regional issues. So we have to keep only data sets of Dodoma, so as we can make it can be easy for us to do some analysis. We have in data set there is a code, a regional code. For example, Dodoma it's 1, Arusha is 2, Kilimanjaro is 3. So you have to keep these codes in your mind that once you drop, you have to use these codes to drop certain regions. So for us, as I told, Dodoma it's 1. So I'm going to keep the question related to regionals to keep only 1. So if the values are 1, then will be keep, the other will be deleted. So this command will keep just the data of Dodoma and leave other deleted. So this is how I keep. So out 15,000, almost 15,000 data observation has been deleted, and we remain with only remain with only Dodoma. As we remain with only Dodoma, as you can see, once I browse the variable, you can see we will have only only data of Dodoma. Yeah, now you can see that we have only Dodoma dataset. So for now, for us, just it easy. So we have a product over there consumed by households. As you can see, these are okay. Let me browse with items. With item, as you can see, food items, item code. Okay, you can see how it looks. So these are the products which are consumed in Dodoma in terms of kilograms. So in terms of the kilograms, these are the products which are consumed by people of Dodoma. It's comprised of rice and so forth. So for next step is to sum up those households who consume rice should be some to some only rice, to some maize, and so forth, to have an aggregate to some those daga and so forth. So how we can come up with this variable? So first things we have here our command here. So the next step is to summarize, to find summation of all programs of the same product. So we're going to sum by item code. So those item unique, I mean those the same item code should be we must to get a sum of the those item code. So here first we have we have to generate a new variable. We have to generate new to generate new variable called the total product, but it should be by item code. Those by item code, then we are going to sum up by item code from those. I mean, value of value of those gram generated from each specific item code. This will be a new command or which I can paste here. Okay, wow. For now, I can browse our data sets to see how data sets it look like after creating summations by item codes. So I can browse here and see how new products are generated. So you may find that each from each observation there is summations of the specific code. As you can see that we have here in rice, we have in hacked rice, we have here in maize greens, we have summation, we have here in maize grains, and so forth. So here is how we come up with this observation, as you can see here. For now, the second step is just to keep it one, because it is a uniform for all item codes. So we have to keep it at one, and uh, uh, just how to keep it at one is just to just first we have to sort it, just to arrange it, in either in descending order. We have to set it just to in order to arrange it from larger to from maximum to minimum. As you can see that we have maximum here over down here. It's about tomato. So for now we have to keep it one. So we have to create some number over here, which we have to create just it's like a frequency. How many are they? Then you are going to keep just to account if there is a duplicate. We have to keep one. So we have to look on this duplicate. There is a duplicate here. So we have to keep one to account for the value of a certain product, a specific product, as you can see from our data set. So we have here a good command. Our command here is just to generate a duplicate values, to generate a new variable which will account for a duplicate issue. Okay, so once I browse it again, okay, once I browse, we have new duplicate value. So you may find that we have if there is one than if the its frequency is more than one, it means it is a duplicate. For us, in issue of lemons, buns, pipe banana, it's 000. So there is no duplicate over here. While for the issue of Chinese and other product, as you can see, there is duplicates. We have onion 1, 2, and so forth. These are duplicates. You can see that we are daga 1, daga 2, daga 3. So we have to drop those duplicates to remain with only one. So for us here, we have a command on how to drop once a duplicate is greater than one. While once the duplicate is 0, it means it's only one variable per per item code. So we have to drop those duplicates to remain with just one variable, as you can see here. As this is a STATA command to drop those duplicates. Okay, now we drop the duplicates, and once I browse it again, data set, I can find that there is only 0, 0, and 1. So it means we have remain with just 0 and 1 duplicate. For now, this is a total, just for tomato, total for maize, total for rice, and total for beans. It is arranged in ascending order from the lower to the larger, so to the big one. So for us, because we need just only top 15, so we have to just to keep only those 15. As you count from the bottom, you may find that it is from, you have to keep only larger 15. So you have to keep from observation 23 to observation 37, as you can see from our data set here. To have 15, top 15, you have to keep from 23 up to 37, as I told you from my my command here. So I have to delete them. So I mean to keep. As I told earlier, keep and delete is have the same meaning. So I have to keep only 10 best 15 observation. As you can see that, then I can browse to see I mean a total and an item by item code, as you can see how they look like after deleting or after keeping the best 15. Okay, now we have this data sets. I mean, we have these summations. So for now, just is issue of drawing a bar, I mean, the peer chart using this observation. So just easy. There is seven. We can draw it using STATA, but for good to do some manipulation, is better to draw it using I mean Excel. So just you have to copy it and open your Excel sheet, as you can see here, and just paste. Okay, there is long uh, with my Excel, but let me open it a new one so I can show you how I can create a new sheet with this data set. As you can see that, and I can draw a pie chart from out of these data sets. As you can see, this is my, okay, I didn't copy it well. Okay, I have to copy it, then I have to come here to insert, then I can draw those from my data set. As you can see here, this as a best 15 in terms of consumptions. As you can see, in percent wise, actually I've started with a smaller one, and the larger one is tomato. It's behind here. So just now, just it's easy for you. You have to just you can do whatever you want. You can expand it. You can add some labels. As you can see, this is not in percent. Okay, I can add. Okay, these are not in percent. Okay, now I did what's format data sales. Okay, we can add now. You can do some maneuver. You can add something here. You can change colors. There are lots of stuff you can do over here related to I mean related to data sets. You can add a variable. You can change it to I mean to whatever you want. You can remove some of your items, or you can do whatever you want based on your request. Here you can put it in percent. You can remove value and remain with percent, as you can see here. So I think this is the end of my training today. I will share all of these do files and starter do files, so as you can work with yourself and your laptop, come up with the same what I did here. Thank you. See you next time.